Here's a video that had the workout solution of the test 3 study guide questions. So I'm going to begin with question 1. Test whether mu1 is less than mu2 at the alpha equals 0.02 level of significance for the sample data shown in the accompanying table. Assume that the population are normally distributed. Okay. So we want to test that mu1 is less than mu2. This is the alternative hypothesis, and the null hypothesis, as you know, should be always mu1 equals mu2. So our choice will be C for HO and H1. Remember, HO always have the equality statement, and H1 has less than, greater than, or not equal to. Now, since these are two samples, two independent samples, we should have a summary of the data. This is a summary of the data. He gives you N, he gives you the sample mean from the first sample and the sample mean from the second. He gives you S. Once he gives you S, guys, you know it's a two-sample t-test. So we're going to go to turn the calculator on. You go to Stat, Tests, two-sample t-test. Not a z-test. We only use a z-test when he gives us population standard deviation sigma, which is not the case. Okay, I've already entered the data, so speed up the time. You can see the data right here. I chose less than now. For pooled, by default should always be no, unless if he states in the problem assume population variances are equal, or assume sigma 1 square equals sigma 2 square. Otherwise, guys, by default it should be a no. We hit calculate. Let me close this. Okay, you get the test statistic and you get the p-value. He didn't ask for the test statistic, they usually do, and he asked for the p-value. You enter the p-value, which is 0.00, how many decimal places? 3, so will be 1. And you know this p-value is less than alpha, so what's your decision? Reject HO. If you reject HO and your claim is in H1, you support the claim. So you say there is enough evidence to support the claim that mu1 is less than mu2, and that would be this. Next question. To test the belief that sons are taller than their fathers, the student randomly select 13 fathers who have adult male children. So it seems like, you know, the two sets are dependent, father and son. So this is different. This is dependent sets. She records the height of both the father and son in inches and obtain the following data. Are sons taller than their father? Use alpha equals 10% level of significance. Note a normal probability plot and box plot of the data indicate that the differences are approximately normally distributed with no outliers. So let me show you the data. So here we are testing the difference. We're not testing this set against that one because the two samples are dependent. We have to do the differences. I wouldn't give you something like that on the test because to subtract the differences, it's a lot of work, you know, to input this. So it will be a much easier two samples to work with. What I'm gonna do, I'm gonna show you how to do this one using Statcrunch, because Statcrunch can do it automatically without having to input the data. So first of all, let's answer some of the questions here. What conditions we must have in order to run the difference, to test the hypothesis on the difference? Okay, the sample size should be always, these are fixed, they don't change. The sample size is no more than 5% population size. The resultant sampling method the samples are dependent, which are fathers and sons. And the sampling method, okay, what else? So we said the sampling size is no more than 5%. The sampling method results in dependent samples, and the difference must be normally distributed. And they said that they indicate the differences are normally distributed. Where does that say that? Difference. Oh yeah, the difference are normally distributed. Now, write the hypothesis for the test. The difference is fathers minus sons. So he's giving you a hint, guys, that you have to subtract. And when you subtract fathers minus sons, you will get only one set. So it's going to be a t-test. For this section, which is section 11.2, you do a t-test on the differences. Okay, what do we want the difference to be? The question is that the sons are taller than their father. What does that mean? Let me just bring a whiteboard and explain that to you. And he says do father minus son. So father minus son. They want us to test that the sons are taller than their fathers. So here's how I would figure this out. I just give the father some height, let's say 70 inch, 68 inch. And they want the sons to be taller, so let's make it 70. And then you guys subtract 68 minus 70. What do you get? You get -2, correct? And -2 is less than 0. So then you need to test that the mean of the difference is less than 0. That is the alternative hypothesis. So now if I go back, I need mu of d to be less than 0. And this is always an equality sign, guys, in the null hypothesis. Now, how do you find the test statistic? I'm going to show you how to do this one using Statcrunch. We're not using the critical value at all. It's always a p-value approach. So you click right here, open in Statcrunch. And then you go to stat. The samples are dependent. You go for t-stats and paired, guys. Paired means dependent. Paired. Select column 1. Okay, they said father first and then sons. And then I'm going to show you the difference, guys. You see, we're testing mu d equals mu1 minus mu2. Mu d is less than 0. And we want that to be less than 0 right here. And I'm going to hit compute. You can see that. And you get the test statistic t, and you get the p-value. So the test statistic is -0.0196, and the p-value is 0.493. And not only you get the test statistic, you get the differences as well. If you were to do this on the calculator, guys, this is what you had to do. You will have to subtract 66.7 minus 71.6. You get the number. Do this and same. And then once you're done, you enter all of those in L1 using your calculator, and you run a t-test. So I'm just going to show you how you would have used your calculator. So you would have done on your calculator, you would go to stat, edit, and in L1, guys, you enter all those numbers, -4.9, that's it, and then -3.6, etc. And then you go to stat, tests, t-test. It's a t-test against 0. Data, you must select data because you have the data in L1. And this is against 0 always, and then L1, and then less than, because we're doing less than 0, and then you hit calculate, and you should get the same exact results, t statistics and p-value. Okay, so I'm going to be done here, and I'll show you the completed solution. And here he didn't want the p-value. He says is the p-value you choose, it's in the range of between 0.25 and 1. And since alpha is 0.05, so the p-value is more than alpha, you fail to reject the null hypothesis. And if you guys fail to reject the null hypothesis because the p-value is greater than alpha, you conclude that there is not enough evidence at the 5% level of significance to conclude that sons are taller than their father. You only can conclude that if you reject the null hypothesis. And since we were not able to reject the null hypothesis, we cannot make this conclusion. So there is not sufficient evidence to conclude that sons are taller than their fathers at the 0.05 level of significance. Next question. Okay, a manufacturer of colored candy states that 13% of the candies in the bag should be brown, 14% yellow, 13% red, 24% blue, 20% orange, and 16% green. This is a question from section 12.1. A student randomly selected a bag of colored candy. He counted the number of candies of each color, and we have them right here. 60, 67 yellow, 52 red, 63 blue, 84, 64. Okay. Test whether the bag of colored candy show the distribution stated above at alpha equals 0.05 level of significance. This is a goodness of fit test, guys. You're testing if a certain distribution remains valid or not. So here's how you choose the null and the alternative hypothesis. Actually, it is easy here. The distribution is as claimed by the manufacturer, and then H1 it will be the distribution is not as claimed, so you should it should be A. Now, the next step is asking you for expected values. Guys, in order to find the test statistic and the p-value, you need the observed values, which are given to you right here. These are the frequencies, these are the observed values, but you need the expected values. You got to do those by hand. Here's how you do them. For the first one, so how many total do we have? First of all, you need the total. So you add 60 plus 67, which is 127, 179, 82, 242, 246, 326, 330, and 390. So we have a total of 390. How do you find the expected counts? For brown, he says, how many are brown? 13%. So you just do, guys, 0.13 of 390. So that will be 0.13 times 390. And what would be the answer for this? You just do it on your calculator and find the answer. So I got 50.7. I'm gonna so just leave it 50.7 if you like. And then for the next one, for yellow, guys, he says 14%. So that will be 0.14 times 390, and that's equal to what? 54.6. Okay, so I input the other values. The red is 13%, 24% are blue, so I did 0.24 times 390, and so on and so forth. So the frequency, again, guys, are called the observed values, and these are the expected values. Then I went to the calculator stat, edit. In L1, you enter the observed frequencies. In L2, I enter the expected frequencies. And then you go to stat, tests, scroll up. It's a goodness of fit test, guys. GOF test. Enter. Are the observed values in L1? Yes. Expected values in L2? Yes. Degrees of freedom. Let me tell you what the degrees of freedom is. Number of categories minus 1. I got 1, 2, 3, 4, 5, 6. Minus 1 will be 5. So that is correct right here. And then you hit calculate. Okay, so the test statistic is 15.062. And the p-value, guys, use the calculator, 0.0101. And what is alpha here? Alpha is 0.05. This is less than alpha. Now, where is the claim? Let's see what the question is. Test whether the bag of colored candy follow the distribution stated above. So the claim is in HO. Okay. So we reject HO, and we say that there is enough evidence to reject the claim because the claim happened to be in HO. So there is a sufficient evidence. I think it's going to be this one. No. There is sufficient evidence. Distribution of color is not. Oh, we reject HO. Do not reject HO. Okay, I was looking for options. It seems to me like this is the only option, which is good. So we reject HO, and there is sufficient evidence that the distribution is not the same as stated by the manufacturer, because we are rejecting the manufacturer claim. Okay, so that is number 2. Okay, we're gonna go now to the next one. Which of the following is not a true statement about error and hypothesis testing? It is C, guys, because type 1 error is making the mistake of rejecting the null hypothesis when it is actually true. So that would be the one. Okay. Now we're doing section 11.1. Insurance company collects data on seat belt among drivers in a county. Of 1,100 drivers, 29-year-old, 30% said that they buckle up, whereas 383 of 1,300 drivers said that they did. At the 1% significance level, do the data suggest that there is a difference in the seat belt use between drivers 20 to 29 and those 5 to 64? Difference, guys, means not equal. So go to the alternative hypothesis and see which one has not equal. It seems to me, guys, that this is the one only. So it's C. P1 is not equal to P2, and HO is always an equality sign, so that's the one. Now, how do you do the test? It's a 2 proportion Z test. So you go to stat, tests, 2 prop Z test. That's for 11.1. Okay, X1. X1 is the number of successes from the first sample. He didn't give us X1. He said 30%, but 30% of what? Of 1100. So you guys, you just put 0.30 times 1100. Oops. N1 is 1100. X2, he says, whereas 383, so he gave us the number, which is good, of 1300. And we want to test that P1 is not equal to P2, as you notice, and hit calculate. So test statistic Z is 0.29. The p-value, guys, is 0.7736, which is more than alpha, so you fail to reject the null hypothesis. And when you fail to reject the null hypothesis, you say there is not enough evidence to support the claim. So there is not enough evidence to accept HA. That's it. Not reject HO, sorry, fail to reject HO. We don't have enough evidence to accept. All right. Next question. All right. This is section 12.2. Section 12.2. If you are in my Math 141 section 59, don't worry about this question, because 12.2 is not included on the test. The contingency table shown to the right gives you a cross classification of a random variable of values for 2 variables, X and Y, of a population. Find the expected frequencies. Note, you will first need to compute the row totals, column totals, and grand totals. We're not going to do any of this, guys. I want to show you how to do it without doing any calculation. So here's how you're going to do it using the calculator to find the expected values. You go to second, you go to matrix, and you go to edit, enter, and now look at the observed values. He gave us a table that has 2 rows of data and 2 columns of data, so you need a 2 by 2. Enter. Enter the values: 50, 10, 40, and then 30. All right, and now, guys, you can quit. I'm gonna quit. I'm done. And now I go to stat, tests, chi-square test. For this section 12.2, it is a chi-square test. It's right here, guys. See, enter. It's telling me the observed values are in matrix A. Yeah, this is where I put them. It's the calculator by itself is going to put the expected values for me in B. So watch, calculate. I got the test statistic. You input that in part B, which is 10.40. I got the p-value, which we can use to decide whether to reject HO or fail to reject HO, and so on and so forth. But let me show you the matrix now, B, because you need to input those values in here. You click on second, matrix, go to B. You see B is 2 by 2 now. Press enter twice. And are the values. So he says 2 decimal places, so it will be 41.54, 18.46, 48.46, and 21.53. And if I go to the test, because I need it for the second part, calculate. So here goes 10.403. And then what are the null and the alternative hypothesis? For this section, guys, for independence test, the null will be the variables are independent. The alternative will be the variables are not independent, means dependent or related. So are not associated, are associated. Are not associated means they're independent. Associated, that means they are related. P-value, guys, we did it, which is 0. It says how many decimal? 3001. And alpha is 5%, so the p-value is less than 5%. We reject HO, and let's see where the claim is here. Decide at the 5% whether the data provides sufficient evidence to conclude that the two variables are associated. So the claim is in H1. So we reject HO. Once you reject the null hypothesis, guys, you support H1. So there is enough evidence to support the claim that the variables are associated. All right. Don't need this message. Okay. Next question. This is two proportion Z test, guys. It's about the proportion as well. Conduct the following test at the alpha equals 0.10 level of significance by determining the null hypothesis, alternative, test statistic, p-value. Okay. Test whether P1 is not equal to P2. So this is your alternative hypothesis, and your null will be P1 equals P2. So let's find one. That will be this. Okay, let's go to your calculator. Stat, tests, 2 prop Z test. This is section 11.1, guys. X1 is 28, and 1 is 255. Should be easily be able to do a problem like this. 38, and then 301. And then P1 not equal to P2, that's what we want in the alternative, and hit calculate. And the test statistic Z will be negative 0.59, so it's negative 0.60. The p-value, guys, is 0.5503, or 3 decimal places, so just 0. This is bigger than alpha. You fail to reject the null hypothesis, and you fail to. So there is not sufficient evidence to conclude that P1 is not equal to P2. It's right here. All right. This is again section 11.2, the difference between two samples that are dependent. How do you know, guys, if two samples are dependent? If they give you an action before and after, or they give you the name of the player, a person, before something and after something. That means the two samples are dependent. The pass completion percentage of 10 college football quarterbacks for the freshman and sophomore season are shown in the table below. At alpha equals 5%, is there enough evidence to support the claim that the pass completion percentages have changed? Have it changed means that they are different. They are different means that it's different from 0. If he says less than, greater than, then you have to use probably less than, equal to, 0, greater than, equal. But he says have it changed, it will be different from 0. So the pass completion rate have changed. This is the claim. And now here's how you select the null and the alternative hypothesis. I'll just show you right here. Okay, let's delete it. So change, guys, means this. Remember that. You need the mean of the difference to be not equal to 0. That would be your claim. Or not. But we still need to do the differences. And what I'm going to do to save time, I'm just going to do this using Statcrunch. So I'm going to open the data in Statcrunch. Watch. Bring it right here so you can see it. I don't care the player name, I don't care about that. So you go to stat, T-stat, it's a T-test. Paired, select column 1, completion percentage, select column 2, sophomore. I want the difference to save them. This is one way, guys, to get the differences, and compute. Or did I choose different from 0? I didn't, but it's already done by default, so different from 0, and that's what we want. Okay, the test statistic, guys, is negative 1.131 and the p-value is 0.2871. And since the p-value is more than alpha, you fail to reject HO and you say that there is not enough evidence to support the claim. And look, these are the differences. They're done for you. 67.4 minus 66.9 is 0.5, etc. If you are to do the differences, guys, and do this on the calculator, here's how you do it on the calculator. So you enter the differences in there. Let me just show you clear. Okay, I entered the value in L1, values in L1 already, guys. So you go to stat, test, t-test. Against 0, don't forget. I put the data in L1, don't change the frequency, it's always 1, and we're testing not equal to 0, and hit calculate. And here you go, guys. It's exactly what we got when we used the Statcrunch. So we're choosing not equal to 0, E, and the test statistic, guys, it is negative 1.131. The p-value is 0.287, and fail to reject the null hypothesis. There is not, every time you fail to reject the null hypothesis, you say there is not enough evidence to support the claim that the completion rate have changed. Changed could be increase or decrease, either one. All right. All right, we did this one. I don't know why it is in the review. Again, this is about sons are taller than their fathers, so we're gonna skip this one. Okay, let's do this. Listed in the data table are amounts of strontium 90 in a simple random sample of baby teeth obtained from residents in 2 cities. Residents in 2 cities means the samples are independent, guys. Assume that the 2 samples are independent, simple random. He says that. Selected from normally distributed. Do not assume population standard deviation are equal. That means pooled is no. This is section 11.3. Even if it doesn't say that, you also assume under pooled when you use a calculator, that's a no. Use a 10% significance level to test the claim that the mean amount of strontium 90 from city 1 is greater than that one in city 2. Greater, guys, means greater than. So let's look for alternative hypothesis that has a greater than. You cannot choose D because it doesn't have the equal sign in HO, so you must have the one that has the equal sign in HO, so it's C. How do you do this one? I'm going to show you how to do it using Statcrunch, and then we'll do it using the calculator. Opening Statcrunch. It's a 2-sample t-test if using the calculator. All right. Okay, let's go to stat. T-stat. It's mostly t-stat. 2-sample, guys. With data. I don't have with summary. He gave me the actual data. Select column 1, city number 1. Select column 2, city number 2. We're doing different. mu1 minus different from 0. So that's good. That's what we want. And let's hit compute. Okay, here's the test statistic, guys. It's 1.433 and the p-value is 0.1713, which is bigger than alpha. Failed to reject the null hypothesis. Now let me show you how to use the calculator to do this one. Okay, guys, so I entered the data in L1 and L2. Again, on the test, you won't have any large data sets. And actually, this is not a large data set. You can easily enter that. So you put city 1 in L1 and city 2 in L2. And then you go to stat. Anytime you have data sets, guys, it's a t-test. Since we have 2 of them, we choose 2-sample t-test. Okay. Data, L1, L2. Don't change the frequencies. We're doing that. The first one is bigger than the second one. So watch, guys. How do you choose? Greater than. And then pooled is no, because he says do not assume that population variances are equal. And then hit calculate. And this is the test statistic. This is the p-value. So the test statistic is 1.22. P-value is 0.120. This is bigger than alpha. We fail to reject the null hypothesis. If we fail to reject the null hypothesis, we cannot support the claim. So let's check which one says that. There is not, every time fail to reject, guys, you have to start with there is not sufficient evidence. So it can't be the first one. It can't be B because it says reject the null hypothesis. Here it can't be C, it must be D without even looking, guys. That's the only one. Okay, here's another one, a 2-sample t-test. Listed below are time intervals between eruptions of a geyser. Assume that the recent times are within the past few years. The past times are from around 20 years ago, and that the 2 samples are independent. Once it says independent, guys, it's a 2-sample t-test. Okay, do not assume population standard deviation are equal means pooled is no. Does it appear that the mean time interval has changed? Has changed means the first one is different from the second one. If it doesn't say greater than, less than, means different. Which one has the different? It's this one. How do you do this one, guys? You put the data, if you use your calculator, you put the recent in L1, you put the past in L2, and then you go to stat, tests, 2-sample t-test, and data, choose data L1, L2, and here, guys, you select different from, and for pooled is a no, and then you hit calculate. But for the sake of time, I'm going to do it using Statcrunch. Watch. It's very easy using Statcrunch. So stat, t-stat, 2 samples, not paired, they're independent. Actually, if they were paired, they have to be the same size. Look here, guys, this has more items than the second one, so they can't be dependent, impossible. 2 samples with data, select column 1 recent, select column 2 past. They're not pooled, no pooled here, so leave it alone. And then just different from 0, which works well because by default the difference is always chosen for us. Compute. And look, guys, this is the test statistic, negative 2.04, and this is the p-value, 0.052. Okay? So negative 2.04. I don't, was 0.052 probably. Okay, what's alpha here? Oh, is the conclusion affected by whether the significance level is 0.10 or 0.01? Definitely. If the significant level is 0.10, this will be less than alpha. We reject the null hypothesis and support the claim. But if alpha, guys, was 0.01, p-value will be bigger than alpha, and we failed to reject the null hypothesis, and we said we don't have enough evidence to support the claim. So for 0.01, reject HO because the p-value is less than or equal to significance level alpha. There is enough evidence. Yes, the conclusion, yes, is affected by the significant level alpha, because if alpha was 0.01, we will fail to reject the null hypothesis. And can you guys see which one is going to be? Yes, this one. Because H0 is rejected when significance level is 0.10, but it's not rejected when significant level is 0.01. Okay, determine whether the samples are independent or dependent. You can see, guys, the samples, because it is the same day in the morning and in the afternoon, before and after, the samples are dependent. All right. Next question. Okay, this is from section 12.1, goodness of fit test, guys. He says the table below shows lists the frequency. Once he says a frequency of wins and give you more than 2, it's always observed values. More than 2 observed values, you know it's a GOF test. A post position of 1 is closest to the inside rail, so that the horse has the shortest distance to run, because the number of horses varies from 1 year to year. Only the first 10 post positions are included. Use a 0.05 significance level to test the claim that the likelihood of winning is the same for the different post position. Based on the results, should bettors consider the post positions of a horse race? So we want to test the claim whether, regardless of the position of the horse, you know, the number of wins is going to be the same. This is a goodness of fit test. And we have to choose the null and the alternative hypotheses. So I'm going to show you how this is choosing. Okay, guys, for this one, for HO, you choose the statement that says the distribution is as claimed, and for H1, you choose the statement that's very close to the distribution is not as claimed. Here, the one that I found was wins occur with equal frequency. So that's what the distribution they are claiming, they're expecting. And H1 should be the total opposite. So at least one post position has a different frequency. That is the language that I found. But in other problems, guys, it's going to be probably distribution is as claimed, distribution is not as claimed. This is a goodness of fit test. You need the observed values and you need the expected values, and you have to do the expected values by hand. The ones that are given to you, guys, so we have 10 categories here, 1, 2, 3, 4, 5, 6, 10, and you have the 10 frequencies. So look what I did here, guys. I put the frequencies in here. Okay, there's one should be 11, the last one. 5. And then 11. Okay, enter. Now I need the expected values. Unlike the other problem that I did before, he gave us for the colors a percentage, and we did a percentage of the total of each. He didn't give me any percentages, but he says that test the claim that the wins are the same regardless of the position. So we expect all the horses, regardless of their post position, to have the same number of wins. Here's what you do, guys. You count the total, which is 115. And since we want the same wins for each one of them, you just take 115 and divide it by 10. What is 115 divided by 10, guys? It's 11.5. So you just go to the list. right here, and you just enter 11.5 throughout. If you had 8 positions, you divide 115 by 8. If you have 6 horses, you divide 115 by 6. So it is always the total divided by the number of categories when he doesn't give you percentages. Oops, sorry. Why the calculator is acting up. Oops. Okay, guys, so now let me run the stat tests, scroll up, goodness of fit test, enter L1, L2. What's the degrees of freedom? Number of categories -1. So I have 10 categories, -1 will be 9, and hit calculate. And here you go, guys. You see 16.739. That's what the system shows me as an answer. Look at the p-value, 0.053. So that was correct. At 0.05, this p-value is bigger than alpha, guys. So you fail to reject the null hypothesis. And where is the fail to reject? It must be B, guys. Not B, right here. So fail to reject the null hypothesis. There is not enough evidence to warrant rejection of the claim that the likelihood of winning is the same. We could not reject the claim. And that concludes the question. Okay, this is another question from section 12.2. Students in section Math 141, section 59 don't have to worry about this one, but I'm gonna do this one. Okay, before we do it, guys, we have to prepare the matrix. So let me clear here, second, and matrix. You go to edit, enter, and then what do we have here? I have a data set that has 2 rows and 2 columns. So that's good. I have a 2 by 2. And then I'm going to enter 207. And then I'm going to enter 810. You don't need, guys, to follow direction and do the totals. You can just do it in one shot here, unlike how the book did it. So I'm giving you the shortcut on the calculator. Okay, I can quit now. I don't need this anymore. I can clear this screen and done here. The accompanying table shows the results of challenge referee calls in a major tennis tournament. Use 5% significance level to test the claim that gender in the tennis player is independent of whether a call is overturned. Remember, the null hypothesis is the variables are independent, and the alternative, the variables are dependent. So let's find which one says that. Independent is not independent. So that's it right here. A. Now the test is statistic, guys. Let's go to stat, tests, scroll up, enter, A, B, calculate, and the test statistic is 60.914. The p-value, you see, no critical value. It's all p-value. You don't have to worry about critical values. As I said, 0.008, how many decimals? 4 decimal places, so it's 86. And alpha is 5%. You know the p-value is less than alpha, we reject HO. And if we reject HO, we say there is enough evidence to reject the claim, to warrant rejection of the claim that the gender of the tennis player and is independent of the of whether a call is overturned. No, let's see which one here. There is sufficient evidence to warrant the claim gender. It's right here. See, okay. Can look at it. You can pause and just look at this. Okay, another example of section 12.2. Again, Math 141, section 59. Don't have to worry about this. And here, guys, you see a matrix of 3 by 3. So I'm just going to go right away to a matrix. Edit. A. And I need to change it to 3 by 3. Enter. And then enter the values. 54, enter. 5, enter. 44, enter. 35. You see how straightforward it is using the calculator. 30. Oops. 30. Oops, I have to go back and change it because it didn't do 30 for me. And now 48. 8. 55. And I'm done here. Or that the first one should have been 54. Okay, now I think we're good. So you can quit. And if you guys want to run the test before even we answer any question, you can. It's a chi-square test. For section 12.2, it's chi-square. And calculate. So, jump direction is independent, jump direction is dependent, so that must be this. Test statistic, guys, is 4.9662. P-value, you can see it's 0.2912. Do the results. Okay, so there is we failed to reject the null hypothesis because 0.2912, guys, is bigger than 0.05. There is insufficient evidence to warrant rejection of the claim that direction of the kick is independent of the direction of the goalkeeper jump. All right, so let's go to the next one. This is section 13.1, ANOVA. That should be a very easy, guys, question to answer. When you have 3 different samples, guys, you know it's ANOVA. So what you have to do, you have to enter the data in L1, L2, L3, and run a one-way analysis of variance. So let's read this question. The data found below measure the amounts of greenhouse gas emissions from 3 types of vehicles. The measurements are in tons per year, expressed as CO2 equivalents. Use a 2.5% significance level to test the claim that the different types of vehicle have the same mean amount of greenhouse. Okay, for this section, guys, 13.1, HO should be always mu1 equals mu2 equals mu3. If you have more, equals mu4 equals mu5, etc. And H1 should always be this language. At least one of the means is different from the others. So which one comply, guys? I think it's D. So that should be your null and alternative. If I give you 4 data sets, just add equals mu4 right here. And H1 does not change at all. I'm gonna show you guys how to do this one with Statcrunch first, and then we'll do the calculator. You go to Stat, you see where it says ANOVA, one way. How do you select all of them? You hit the press down the control key and select them. And I think that's it. Compute. And you need, guys, this. You don't need anything. Although in the book he shows the detailed work on how to find F, you don't need to worry about it. Just get F from the calculator. And he says the p-value is less than 0.001, which is very small. p-value low, HO must go. So the p-value is less than alpha, we reject HO. And that's how you get it in Statcrunch. Now, how do you do that using the calculator? Let me show you. All right, to use TI-84, guys, you input the data into L1, L2, L3. And then you go to Stat, and you go to Tests, and then you go up, and then you select ANOVA, Analysis of Variance, and now second and number 1 will give you L1 and put a comma. Second and number 2 will give you L2 and put a comma. Second and number 3, L3 and close parentheses, and enter. And here you go, guys. You see it's the same as Statcrunch. The test statistic is 37.37. The p-value, guys, it's very, oh, it says E minus 8. E minus, don't ignore it. Don't write an answer 2.476 or 4.2476. E minus 8 means you have to move the decimal point 8 digits to the left. So there will be, we need 7 zeros. There will be 0.000004. So actually he says 2 decimal places. You just put 0.00. That is the p-value. Conclusion of the test. Reject HO. When the p-value is low, guys, you reject HO. And so we reject HO. That means HO is bad. That means at least one of the means is different. That means the type of vehicle does matter. So conclude that the type of vehicle does appear to affect the amount of greenhouse gas emissions for these types. Okay, let's see. Another question on ANOVA, I believe. Let's see. Refer to the accompanying data table which shows the amounts of nicotine, milligram per cigarettes and king size cigarettes, 100 millimeter menthol cigarettes and 100 non-menthol cigarettes. The king size cigarettes are non-filtered, while the 100 menthol cigarettes and the 100 non-menthol cigarettes are filtered. Use a 0.05 significance level to test the claim that the 3 categories yield the same mean. So mu1 equals mu2 equals mu3. Here you go. And do you guys still remember what I said about H1? At least one of the means is different from the others. There you go. And how do we do this? I'm going to do it in Statcrunch because it's going to take me time to put those in. You don't put the brand as a list. You put just the those values in milligram. So it's L1, L2, L3, not the brand. So I'm going to open it in Statcrunch. So now you learn how to do it in Statcrunch. Oh, it didn't even put the brand. So that's good. That's all we need. So Stat, ANOVA, one way. We don't do two way in this. Okay, but hold down the control key and select them. And look, guys, you hit compute. And the test statistic is 7.99 and the p-value is 0.0019. That's all I need. Or was it 7.99? And the other one 0.00, I don't remember, whatever. And this is less than alpha. If it is less than alpha, then what do you guys conclude here? Sorry, I had to go back and look, guys. So the test statistic is 2.99. It says 3 or 4 decimal places. And alpha is 0.067, sorry. So if this is the case, okay, I input the answers in there. So we fail to reject because this is bigger than alpha. Alpha is 5%, guys. So bigger than alpha, there is insufficient evidence to warrant rejection of the claim that all the 3 means are equal. In conclusion, guys, if the claim is in HO and you reject HO, here's how you write your conclusion. You say there is enough evidence to reject the claim. If the claim is in HO and you fail to reject HO, you say there is not enough evidence to reject the claim. So you don't use the word support. Now, if the claim is in H1 and you reject HO, you say there is enough evidence to support the claim. Because if HO is bad, guys, and your claim is in H1, then H1 must be good. They can't be both bad. If one hypothesis is bad, the other one must be good for sure. And if you fail to reject HO and the claim is in H1, you say that there is not enough evidence to support the claim. That concludes the review for the test.